Okay, now we are in motion. So let's just read through quickly. So with this one, when referring to moving objects, we have the following. We're still on rate of change. So that means we're gonna find derivatives there. So first one, the rate of change of position with respect to time is called velocity. So what does it mean? I'll write a summary thing here. Let's say our summary will be here. Now with our summary, you're going to be given something that talks about position. So let's say a formula like this. It talks about position. It means where something is. Now, that is, if you find the first derivative, according to the first sentence, if you find the first derivative of that formula, you get what you call velocity. That's what the first sentence is saying. So you're going to get a formula that shows position. Now, if you find the first derivative of that formula, you get what you call velocity. Next sentence, the rate of change of velocity with respect to time is called acceleration. So that means if you take that same formula and you find the second derivative, then they call that acceleration. Now, basically they're doing that. So they're saying ST, the one that I just mentioned now, is the position. So the position can be displacement, distance, or height of an object after some time. So velocity, VT, so this VT, this thing can also be referred to as VT instead of S prime of T. Of the object at any specific point in time, it's given by S prime of T, like I just said now, and it's also called as VT. So this and this, one and the same thing. Now the acceleration of an object, so acceleration of an object, specific time, is given by V prime of T, which is equal to S double prime of T, which is A of T. So this S double prime of T is the same also as V prime of T. Remember, it's basically taking derivative of this. Find derivative of that. Or finding the second derivative of this one. So basically, you can just memorize them based on this ones, because they have to give you this first one. But then note that if they say this is velocity, it's going to be just V prime of T. Now this is also called acceleration. So A of T, okay, S double prime of T. So yeah, all of them are here. Okay, now they go back to minimum and maximum. So for minimum and maximum, again, you're just gonna take that displacement. So it's just S of T. Remember, for minimum and maximum, you just find S prime of T, then you equate it to 0. Minimum or maximum of anything, it's just gonna be first derivative and then you equate it to 0. Never mind the noise in the background. Yeah, and so on. Now, it says the velocity and acceleration can be positive or negative. So when you find them here, when you find first derivative and second derivative, or first derivative of the velocity, which is the acceleration, or second derivative of the position, again, which is acceleration. So those can be positive or negative. So let's talk about that. So the numerical value of the velocity tells us how fast an object is moving, speed of the object, and the sign of the velocity indicates the direction which the object is moving. So if they're saying it's moving west, and then that's the original one, and then now you get negative, that means it's the opposite of west, that means east. As you'll see with the example. So acceleration tells us how rapidly the velocity of the object increases or decreases. Now, for acceleration, or to know whether acceleration tells you whether it's speeding up or slowing down. So if the acceleration has the same sign as the velocity, that is, when you calculate, first derivative and the second derivative have the same sign, that means the object is speeding up. And can be both negative, that means speeding up. But then if they are opposite sign, that is plus and the minus, that means the object is slowing down. Doesn't matter which one is plus, which one is minus. Let's quickly look at this one. So it says the displacement, that's s of t. So s of t, there it is. That means from s of t, if you want to find velocity, you just say s prime of t. If you want to find acceleration, that's double prime of t. As easy as that. Okay, the particle moves in a straight line from east to west. So from east to west. That means the negative direction is east, positive is west. The particle is initially west of P, so here's P, and then it's that way of P. How fast and in what direction is the particle moving after exactly 4 seconds? How far, okay, I read the B. A, how far is the particle from point P initially? Again, this gives you the distance, the position, so you just need to, again, initially, remember before I said initially is when time is 0. So that's why the time there is just 0, and then you get that it's 400 meters. B, how fast, now it's velocity now. How fast, that is first derivative, that is, you just want to find that. How fast and in what direction is the particle moving after exactly 4 seconds? The direction will be whether positive or negative, and now you're just going to choose whether east or west based on the signs. Positive, west, east, negative. In this case. So first derivative, as you can see there, it is. And then now, after first derivative, you just put in 4 to see which direction. So it's negative. So as you can see, where it was going, it was positive. Now the opposite direction will be negative, which is east. So that's why it's 36 meters per second. East. C, calculate the acceleration of the particle. That's the second derivative. So you can just find s double prime of t, which is the same thing as the acceleration they're looking for. And then you get that 6 meters per second squared. D, what is the minimum distance? Again, minimum distance. Minimum or maximum, you take the original, you find the first derivative, you equate it to 0, and then you solve for the time. And then there it is, and then you got the time. The minimum will happen after 10 seconds. What is that minimum? Then you take it, you put it into the original. The original being the ST. This one here. And then that means minimum distance is 100 meters. E, is the particle speeding up or slowing down? Now this is where speeding up or slowing down, this is where you go back to this part. There's 2 parts. Speeding up, slowing down. Speeding up, they have to have the same sign, velocity and acceleration. Slowing down, different signs or opposite signs. Let's see. So, 1, speeding after exactly 6 seconds. So you need to find the velocity after 6 seconds. The acceleration, it's always going to be the same. It's always going to be this. Doesn't depend on the time. Acceleration will be 6. So you find the velocity first. Get that the velocity is minus 24. So now the acceleration is positive 6, velocity is 24. Now they all have opposite signs. That means slowing down. Here the velocity after 12 seconds, it's 12. And then acceleration is 6. Again, don't be confused with this acceleration. Acceleration will always, in this case, will always be the same. Remember, when you calculated the acceleration, you got exactly 6. So it's always going to be 6. That's why we're just always using 6. Now they have the same sign. That means it's speeding up. That's it.